A very big part of any data science project consists of data manipulation, or ETL. A big part of data manipulation projects consist of mathematical operations, string manipulations, and data transformations according to a rule set. KNIME Analytics platform offers some very versatile nodes to perform most of those data manipulation operations alone or together: the math formula node, the string manipulation node, and the rule engine node. To make things even easier, these three nodes have very similar configuration windows. So we are going to show all of them here together in one video. For this example, we will be working on the following dataset containing demographic data. In particular, we want to replace this hyphen with the space character in native country values, round up people's age to the nearest 10, and create three categories of people: unemployed, employed part-time, and employed full-time from their number of weekly work hours. Let's focus on this last task and on the column hours per week. The numbers in this column show the number of hours people work per week and are a good basis to define their employment status. To implement the rule set, we use the rule engine node. The rule engine node creates a rule set and applies it to the input data rows. New values are produced from the rule set application that can be saved in a new column or in an existing column by replacing it. We open the configuration window. Here we have the column list, which shows all available columns from the input data table. Here we have the flow variable list, which lists all flow variables available to the node. Here we have the function panel, which contains the functions and logical operators to be used in the rule set. Notice the category menu on top. Categories represent data types. A category selected here reduces the function list to a smaller subset of functions compatible with the selected data type. On the right, we have the description panel. When a function is selected in the function panel, the description of its task and mode of use is displayed here. Finally, here we have the expression panel, which is the core piece of this node. The expression panel is the rule editor. Here we can define the set of rules to apply. Under the expression panel, we have the option of whether to create and append a column with the new values or to replace an existing column with the new values. We're going to create a new column named Work Status. Now, let's create the set of rules. Let's start from the first rule. If the number of work hours equals 0, then we should set the work status to unemployed. The column to check is hours per week. If we double-click this column in the column list panel, the column name gets automatically inserted in the rule editor already with the right syntax. Now we need to compare the column value to 0. Let's search for the operator equal in the function list. Similar to the column name, if we double-click a function from the function list, it will automatically be inserted in the rule editor with the right syntax. Every rule consists of a condition, including a function, and of a consequence. We have the condition of the rule, so now we need the consequence. This symbol here, made by an equal sign followed by a greater sign, is the symbol that introduces the consequence value. In our case, the consequence value is a word, that is, a string value saying unemployed. Notice that string values must be enclosed in quotation marks, otherwise they will be interpreted as numbers, and the rule engine node will mark this as a syntax error. If a person works more than 0 hours but less than 40 hours, then their status will be part-time. We write the next rule as the third rule states that if a person works 40 hours or more per week, their status is full-time. However, since the rule should include all remaining input data rows, we can just introduce a default condition covering all remaining data as true. This keyword true means that this condition is always true. Since conditions in a rule engine are verified from top to bottom, placing true at the end of the rule system collects all leftover data rows. True has the role of an else in many scripts and programming languages. When we click OK to close the configuration window, a syntax check is run, and if the rule system contains syntax errors, the configuration window does not close until they're fixed. We close the configuration window and we execute the node. We open the output table, which now contains a new column named work status with each person's employment status. Next, we'd like to round up each person's age to the nearest 10. We can do this by using the math formula node, which implements mathematical formulas. The configuration window of this node has the same structure as that of the rule engine node. Here is the column panel with all available columns from the input table. Here is the flow variable list with all flow variables available to this node. Here is the list of functions. In this case, those are only mathematical functions. Here we have the description panel, where a description of the selected mathematical function is displayed. And here we have the editor for the math expression. Again, double-clicking on a column name in the column list, on a flow variable name in the flow variable list, or on a function name in the function list, automatically introduces the object in the math expression editor with the right syntax. Below are the options to save the produced values in a new column or in an existing column by replacing it. For this task, we will replace the values in the age column with the new values. Let's build the math expression. First, we search and double-click on the function round. Then, we double-click on the column age. We round up age to the closest digit on the left of the decimal point. The math expression is then the rounding up of the value age to the closest 10. By default, the node produces double-type numbers. However, it will produce integer-type numbers if the convert to int option is enabled. Again, when we close the configuration window, a syntax check is run, and if the editor contains syntax errors, the window does not close if errors persist. We execute the node and open the output table, where we now have only tens as age values. As a last step, we want to change the values in the native country column by replacing hyphens with the space character. String manipulation operations are performed by the string manipulation node. Again, the configuration window follows the same structure as the ones of the previous two nodes. Here is the column list, the flow variable list, the function panel, the category menu, the description panel, and the expression panel. To implement our task, we search and double-click the replace function. As usual, the function appears with the right syntax in the string manipulation editor. If we check the description text for the replace function, we can see that many variations are possible. We choose the one with the string column to work on, the old substring to replace, and the new substring to use as replacement. Let's double-click the column native country in the column list panel. Again, the column name has now been inserted in the string manipulation editor with the right syntax. Let's add the substring to be replaced as hyphen and the replacement substring as the space character. Notice again that strings are enclosed in quotation marks to be recognized as string. Single characters would be enclosed in single quotation marks. We will replace the values in the native country column with the new values. We execute the node. In the output table, we can see that the composite values in the native country column now have a space and not a hyphen. We hope we've been able to give you an idea of the 3 basic nodes for data manipulation: the rule engine node, the math formula node, and the string manipulation node. These are probably the most useful and versatile nodes in KNIME Analytics platform for performing data manipulation. We've also tried to show that these nodes offer a similar GUI for their configuration window. The key difference in all those configuration windows lies in the different lists of functions.